Hello everyone. Today I'm here to present the topic web mining. So firstly, when coming to the definition of web mining, the difference between data mining and web mining is that data mining is extracting useful information from the data that is available. So it can be available in any medium for that matter. It can be available in a repository or warehouse or online, anything for that matter. When it comes to web mining, it is mining the information that is available in the web. So talking about web, the information that is being posted. Why? Because here in web, everyone has the provision or the rights to post the information that they are willing to post. So we cannot check for the genuineness of the information. So talking about web mining, you have to mine the information which is genuine, which is relevant, which is frequent, or which is true for that matter. So this is what is the basic definition of web mining. And talking about the web mining, our topic for today is association rule. Just like the name implies, association rule talks about the dependency between data. So talking about the dependency, the relationship, or how they are related. What if I choose an item, and what is the probability of choosing one another item for that matter? So as this rule implies, based on its property, it can be categorized into unsupervised learning technique. So there are several examples that follows this particular strategy association rule. The first and frequently used strategy is this market basket analysis. So market basket analysis is nothing but, say I am running a provisional store and how frequently the items are brought together. Say if I buy an item, what is the probability of buying one other item for that matter? So coming to a conclusion based on their frequency of buying them together and their relationship is what is your market basket analysis. And there are several other examples as well, like web usage mining, continuous production. Continuous production in the sense, say if you are into an production industry, how frequently or how far your graph is keep on increasing, continuous production, right? So here for the market basket analysis, they have talked about a real-time example. Say if a customer buys bread, what is the probability or possibility of buying few other items for that matter, be it butter, egg, milk or jam, anything, right? So like this rule implies, if I am buying an item named A, what is the probability or how frequently I'll be buying B? So if A, then B. So here A is called as antecedent and B is called as consequent, right? So this is what how the association rule works. And talking about the format in which the association rule is being represented, it can either be transactional data, and one other format is there that we'll see nextly. So talking about transactional data, like the name implies, you'll denote the transactions that is being made for the day or the week or month. So this is how you'll store the data. Here is an example of how the data is being stored in transactional format, the data of a grocery store, right? So this is sometimes, or it is also called as till roll format, right? Separate item for record for each transaction. The following format or the second format in which you represent your association rule is the tabular data. This is what we usually do. Say I have customers, 4 customers, wherein the probability of this particular customer buying each item that is available in my grocery shop. Say if they buy it, it is marked as true. If they do not buy it frequently, I'll mark it as false. So this is called as tabular data, and this is how I'll store it. Right? This is a traditional format of storing the data, whereas this format is also called as basket table data or truth table data. Now coming to the important terminologies or important metrics that this association rule talks about. There are 3 terminologies, whereas the number 1 is support. Support is nothing but the frequency of any particular item for that matter among the available data set. So in order to identify the support of particular item X, I have to identify the frequency or the number of times it is being repeated out of the total transactions. Here T stands for transactions. So on identifying this thing, or with the help of this simple formula, I can say this is what is the support or the frequency of any particular item named X. The second terminology in our association rule is that confidence. Confidence is nothing but, I was talking about if A, then B rule, right? So what if, or the relationship between A and B for that matter, how frequently X and Y occurs together out of the frequency of X. On identifying this, or by solving this simple formula, I can say the confidence of any particular variable X. Right. The next or the last terminology of our association rule is nothing but lift. So the strength of any rule is what you call it as lift. So on evaluating this simple formula, support of X and Y, X union Y divided by support of X into support of Y. So this variable support, we already know it is nothing but the frequency. The frequency of XY occurring together divided by the frequency of X and the frequency of Y is what is the resultant value, that is lift. Say if that lift is greater than 1, so the resultant value will be a decimal value. If that resultant value is greater than 1, we say that these 2 item sets are related or dependent on one another. Say if it is equal to and or less than 1, we say that if it is equal to 1, they are independent of other. If it is precisely equal to 1, they are independent of each other. If it is less than 1, the other item yes, the other item is a substitute for the first item. The following item is the substitute of the first item. So this is what that is. It has a negative effect. Whereas this particular item, if it is kept together, the other item will be sold, whereas the item being considered will not be purchased or bought or sold. Right. So these are the basic terminology, that is support, confidence, and left, as far as our association rule is concerned. So here I have taken a simple example. Again, a grocery store or a provisional store, and I have few transaction IDs here. I have only mentioned the transaction ID, wherein which I have not mentioned which customer I have brought it. So with this, I am, or the provisional store, being a provisional store owner, I am given that from this given table, this is the variable X and this is the variable Y. That is, if I am buying milk and diaper, what is the possibility of buying beer? So for this scenario, I have to evaluate support, confidence, and left. And here I am. So when it comes to support, it is frequency of all the items A and B out of the total transactions. So milk, diaper, beer, the amount of times or the number of times it is being brought is 2. Milk, diaper, and beer. Again, milk, diaper, and beer. So it is being brought 2 times together, these 3 items, and out of 5 transactions. So the support value, it is 4. That is the frequency of these items that is being brought together. It is 40% out of total transactions. So talking about the confidence defines the relationship or the difference between the items A and B. So on evaluating it with the occurrence of milk, diaper, and beer, that is the total number of occurrences divided by the occurrence of milk and diaper, that is support of A union B divided by support of A. So out of 5 transactions, milk, diaper, beer is bought 2 times. That is the numerator here. And milk, diaper, the probability of milk or the subfrequency of milk, diaper bought together is 3. So their dependency is 67%. Now talking about left, are they completely dependent on one another or not? So on evaluating the appropriate formula, we receive the resultant value 1.11, which is greater than 1. This shows that milk, diaper, beer are dependent on one another. So the probability of buying them together is high, right? So there are several algorithms which makes use of this association rule, namely Apriori algorithm, Elcott algorithm, and several other algorithms. Whereas today we are going to talk about only the Apriori algorithm. So Apriori algorithm, using the metrics or the terminologies that is being used by association rule, it comes to a conclusion that how often is an item is being bought, how often an item is being sold, so that we can identify the relationship or the frequency of the items being bought together. So here is the algorithm or the workflow of this particular a priori algorithm. Here, the picture defines 2 factors, namely, that is min sub and min conf. That is nothing but minimum support and minimum confidence. That is, we have to fix a threshold value for support and confidence in the minimum level, so that every item has to achieve that minimum support and minimum confidence. So we'll scan the database. That is, we have to scan the data that is being given, and we have to scan the items one by one. If the candidate item is obtained is not equal to null, and that condition returns true, you'll end up iterating. If it is not true, we have to iterate it again and increment the value of k. Initially, we have taken k value as 2, that is 2 item set, and we have to reiterate it until this condition returns true. Right? The candidate key or the candidate item is returns empty. Until then, we have to iterate. So this is the step or the step-by-step manner in which we solve the a priori algorithm. So the algorithm suggests that we have to set a threshold value, that is minimum support. This is nothing but the minimum number of times each item has to occur, or the minimum number of times each item has to be frequently repeated, right? Then we have to generate the items one by one. That is 1 item set, 2 item set, 3 item set, until the condition returns null. Now repeating the steps for identifying frequent item set. So we will choose 1 item set, and we have to end up calculating frequent 1 item set. 1 item set in the sense, in my purchase, I'll have only 1 item. If it is 2 item set, in my purchase, I'll have maximum of 2 items. So you have to repeat it until you identify the frequent item set of that particular transaction. So you have to repeat this step 3, 4, and 5. Whereas step 5 is you have to prune the item which do not fall under this threshold value, that is minimum support. This support value is taken by the evaluator himself. So if I am a grocery store owner, I have to set a minimum threshold value, or that is the margin in which the item has to be sold. So this is set by the evaluator he himself. So you will repeat the steps 3 until 5 until the condition fails. That is until you find that the elements are null. So once the association rule is being identified, you'll evaluate their confidence, and based on which you'll identify their relationship. Now let us see how this algorithm evaluates the given item set. So for easy understanding, I have taken a simple items that is being sold in a grocery store. In this case, again, I have taken only the transaction IDs, not the customer IDs. So these are the items. So basically it is bread, butter, milk, cookies, diaper, and beer, 6 items, right? So I have made an assumption that my minimum support, that is the frequency of the items that is being brought is 40%, and their minimum confidence, that is their relationship must be in for about 70%. So I'll identify the candidate item set and qualify them for frequent item step by step. Now let us see how it works. So one item set in the sense how my purchase has only one item and their support count. Support count is nothing but, say if I have 5 transactions, see here I have 5 transactions. Among these 5 transactions, how frequently my bread is being purchased. So it is being purchased out of 5 transactions, it is purchased 3 times, butter 3 times, milk 2 times, beer 2 times, cookie once, and diaper is purchased 3 times. So I have my minimum support and my item set count. Now I have to identify my minimum support count. Minimum support count is nothing but based on this factor only you'll come to a conclusion how far these items are being frequently purchased. So it is 40% my minimum support, and the item set count, that is the total number of transactions, it is 5. So the minimum support count turns out to be 2. So whichever item who do not have their minimum support count greater than or equal to 2 has to be pruned out. So this is what was the step 5 in my algorithm. So I am pruning out cookies, which is brought only once, and I am identifying my one frequent item set from one item set, right? Likewise, I have to identify 2 item sets. 2 item sets is nothing but out of the available items, I have to create item sets that has 2 items in it. So there were 6 items, whereas I have pruned out cookies. So ignoring cookies, among the remaining 5 items, I have to construct my 2 item set. So this is what is the item set, and this is their support count. That is out of 5 transactions, bread butter have together occurred 3 times. Bread diaper is together purchased 1 time. Bread milk, it is purchased together for 2 times out of the five transactions. So I have ended up creating the support count for all the possible 2 item sets. And since my minimum support count is 2, I am pruning out the items who do not have their support count that is greater than or equal to 2. I must prune out. So I have to prune out the values that has 0 and 1. So I'll end up creating my 2 frequent item sets. So it is bread butter, bread milk, buttermilk, and bread diaper beer. Now I have come to a conclusion of constructing 2 frequent item sets. So from here, the next step is to identify 3 frequent item sets. 3 item sets, sorry. So here is my 3 item sets. From here, I have pruned it to 3 item sets. So I'll ignore cookies. On ignoring cookies, I'll construct my 3 item sets. So on constructing, I'll prune out the item sets who do not have their support count that is greater than or equal to 2. In this case, I have to prune out every possible thing, and only bread, butter, milk exists or move on to 3 frequent item set from 3 item set. So here is the resultant. So these are the items that are being frequently brought together, and they have to placed one next to the other in my grocery store or grocery shop, right? From here, I have to identify their confidence. So we all very well know that the formula for confidence and the items that has their frequent item set. So 1 frequent item set, 2 frequent item set, and 3 frequent item set that I have entered calculating. From here, I have to identify, are they achieving their minimum confidence? Confidence in the sense their relationship or their within the other, right? So I have to evaluate all possible things from 2 frequent item set and greater. So taking it from 2 frequent item set, firstly I have bread and butter. So bread, so we all know the formula for confidence, that is union of probability of x union y divided by probability of x. So I have to identify the relationship. If I buy bread, what is the probability of buying butter? If I buy butter, what is the probability of buying bread? So I have to identify bread butter together, it has occurred 3 times, and bread alone has occurred 3 times. So the resultant value is 100%, which is greater than 70%. That is my minimum confidence. So their relationship appears to be strong. Whereas butter and bread is though it appears to be strong. When taking bread and milk into account, union of bread and milk, it is 2, whereas the possibility of buying bread alone, it is 3. So 2 by 3 is 67%. So their relationship seems to be not that strong, right? Close to strong, but they are not strong actually. So what happens is the possibility of buying bread and again buying milk is just nominal, 67%. Wherein on buying milk, the customer tends or aims to buy bread is falls to be on the stronger end. So it is 100%. In this way, we have to identify the confidence for all the 2 frequent item sets. And coming to the 3 frequent item set, so these are the possibility, whereas we have to consider this x and y, right? So you can make all possible combinations of x and y. That is bread butter is x and milk is, that is possibility of buying bread butter, which in turn results to possibility of buying milk, and the possibility of buying bread and milk together, which in turn results to the possibility of buying butter, right? So we have to evaluate every possible combinations, and you have to let us know the strong combinations. So this is how my a priori algorithm works. right? So the a priori algorithm, we have to find frequent item set F1 for all possible combinations, k is number of unique items. For all possible k value, we have to identify item sets, and we have to generate the candidate set generation. That is, the candidate set generation is nothing but that items that is being brought together, right? So on identifying that, we have to do pruning. Pruning is nothing but the item whose support do not fall equal to or greater than the minimum support value that is being set has to be removed for further item set calculations, right? So this is what is about the pruning is all about. So you have to do this iteratively until it is 2 minus or greater than k, equal to or greater than 2 minus k, right? So this is how the a priori algorithm is said to work. Now we'll move on to a simple exercise. Please make a note, and you have to identify the a priori algorithm and their final resultant frequent item set. Yeah, please make a note. And here I have made an assumption that the minimum support value must be greater than 50%, and the minimum confidence must be, again, be greater than 50%. Yes, evaluate it and let me know the solution. Yep. Here is another example or an exercise. Instead of taking some real-time variables like bread, butter, jam, I've given this items that are being numbered I1, I2, I3. So here I have made an assumption that instead of mentioning minimum support in percentage, I have given it in numerics. The minimum confidence must be 50%. Yeah, please make a note. Okay. Yes. So every algorithm must possess a disadvantage. So talking about the disadvantage or a limitation about this a priori algorithm is that, uh, say, there will be items that are being rarely purchased. It can be any thing for that matter. In our previous example, it was cookies. So what if the cookie or the item that is being skipped or pruned out is said to fall on the higher revenue side, right? Say if I am owning a gadget store, the gadgets like earphone, earbuds, keyboard, mouse are all sold out frequently. That will be moved or that are being sold large in number. But when it comes to some PS5 or any gadget whose cost is on the higher end will be purchased later, but it'll be equal to if I'm selling out some 100 mouse or 100 keyboard, I'll rarely sell PS5. But selling out 100 mouse or keyboard is equivalent to selling one PS5, right? So what if that rare item that is being pruned out brings in so much revenue or brings in so much money or anything for that matter, right? So again, there is one other example, that is mining the medical records as mentioned in the presentation. So we have this general flu, which has their symptom as fever and cough. The same thing, uh, SARS, a serious disease or a serious illness like SARS, also has their symptom as fever and cough. So just because someone has fever and cough, we cannot conclude that that fellow is having or he's having an ailment from cough. Also, what if it is in the other side? That is, fever, cough is again a symptom of SARS. We cannot ignore it just like that, yeah? So this is where the a priori algorithm tends or it miserably fails. So there they address a problem called rare item problem. So the name itself implies the problem that is being faced on ignoring a rare item, but they have some serious impact in terms of revenue, money, or whatever, time, or whatever, resource, anything for that matter. So in order to address this rare item, the experts suggest minimum, instead considering minimum support for all the available items, we can set minimum support for every individual item that is available in my market. Say if I'm owning a grocery store, taking up this market basket analysis, instead of setting the minimum support that is common for all items, I can set the minimum support for every individual item for that matter. In that case, while calculating this support or confidence, I'll not fail miserably, right? I'll always take the minimum support for every individual item, right? So that is what this problem talks about. So here is an example of how it works. So every layman can understand. Instead, whereas for bread, it is 2%, shoe, it is 0.1%, cloth, it is 0.2%. So every time I solve, I'll end up calculating or taking minimum among them, right? The minimum value will be taken. So in this way, it is said to support the downward closure property, right? Say if a superset achieves the a priori algorithm, or it falls out, or it tends, or it proves to be on achieve the support or the confidence, their subset also tends to achieve the support and confidence. Support is nothing but frequency, confidence is nothing but the relationship. In that case, their superset also tends to support this property. This property is called as downward closure property. If the superset is achieving the mentioned support and confidence, their subset obviously supports the support and confidence that is being mentioned. This property is called as downward closure property, right? So this is how the a priori algorithm makes use of association rule, and the problem or the limitation or the flaw of a priori algorithm is being addressed. Yes. Here is one another example. You can pause the video and take note of it. Yes. And thank you for watching. I hope you like this session. I hope you like this topic. Please let me know in the comments how useful is this video or what should I post next. And thanks for watching.